bestrobo.in, your favorite robotic and electronics store in India.
Hello everyone, welcome to Vifratech. Today in this section we will learn about a Node MCU esp8266 microcontroller. It is mainly used as a microcontroller. It has a inbuilt Wi-Fi in it. So this is how a Node MCU esp8266 microcontroller will look like. So as you can see, it has a inbuilt Wi-Fi in it. So this Node MCU is an open source Lua based firmware and development board. It is specifically targeted for like IoT based application. You can make use of this. It mainly includes a firmware that runs on the ESP8266 or Wi-Fi SoC from ePress systems, and hardware which is mainly based on the ESP12 module. The hardware based on this ESP12 module. It is a high processing power, inbuilt Wi-Fi, Bluetooth and deep sleep operating features make it a more ideal for IoT projects because you can easily connect to Blink app or any hardware related projects. You can send the data through the Wi-Fi or Bluetooth also. So the Node MCU ESP82 development board mainly comes with the ESP12E module, which mainly contains a ESP8266 chip, which has having this processor, that is a CP2102 or a CS340G. These are the any one of the processor will be present in this Node MCU ESP8266 microcontroller. So the processor mainly supports RTOs and operates at 80 MHz to 160 MHz adjustable clock frequency. So the Node MCU has a 128 KB RAM and 4 MB flash memory in order to store the data and programs. So the Node MCU can be powered using any micro USB jack, or you can also provide through externally. It supports SPI, I2C and UART communications also in order to interface. So what are the specification of this Node MCU ESP8266 means? It has mainly a microprocessor, which I told, that is a CP2102 or CS340G. Operating voltage is between 3.2 to 5 volts. Generally will provide a 5 volts DC supply for this Node MCU ESP8266. The input voltage between 7 to 12 volts. It has mainly 16 digital input output pins. It has one analog pin and one SPI and UART communication pins. It also has a I2C pin, then a flash memory of 4 MB. It has a static RAM of 64 KB, and it has a oscillator, that is a clock. It has a clock speed of 80 MHz. It has a PCB antenna in it. So it has inbuilt Wi-Fi and Bluetooth also in it. So what are the different features of this ESP8266 microcontroller? It is a open source, interactive and programmable. It is of low cost. It has a Wi-Fi enabled, so you can use for you can also use this in order to in Arduino programming also you can do it, and you can connect it to a Blink app. So even event driven API for network application, which facilitates developers writing code running on this MCU. It is mainly used for IoT applications. So next we will see the pinout, what are the different pins present in this ESP8266 and for details about those things. Mainly for powering, it has a micro USB cable, that is in order to dump the code, and also you can provide power supply through that cable. And it has a 3.3 volts pin that will provide a 3.3 volts. You can connect to any sensor or device which require that much of power. And ground pin, this has to connect it to be ground. Next we have V-in pin, that is external power supply in order to provide to this Node MCU microcontroller. And next we have two control pins. One is enable pin and reset pin. Next analog pin, it has only one analog pin, that is A0, as you can see here. Next it has general purpose input output pins, that is from 1 to 16. Total 16 general purpose input output pins it has. Next for SPI communication, it has a serial clock, serial data 0 and serial data 1 and CMB. There are 4 pins present. For UART communication, it has a transmitter and receiver, 2 transmitter pins and 2 receiver pins, that is TXD0, TXD2 and RXD0 and RXD2. Then for I2C communication, it has different I2C pins. So next we will see what are individual pins in this. As you can see, this is how a ESP8266 microcontroller will look like. So as you can see, it has a flash button here and a micro USB port in order to dump the code or in order to provide the power supply. There is a reset button also present in this. It mainly has a CP2102, that is a microchip. Then it has a USB to TTL converter here and a onboard LED that is connected to D0 pin, and a 3.3 voltage regulator is there, and it has a ESP12E chip also. This is the main chip. Then it has a 2.4 gigahertz antenna. As you can see, this one is the antenna. So I told there are 16 general purpose input output pins present. They are mentioned here. As you can see, GPIO 1 to 16 and 3.3 volts pin. This will provide a 3.3 volts and a ground pin here, and a 3.3 and a ground pins present. And it has enable a reset pins, a VIN, that is for external power supply. Then there is a A0 that is for analog pin you can use. And as you can see here, for serial communication we have serial clock and serial data pins, and for SPI we have master out, slave in, master out pins. So these are the different pins present in this node MCU microcontroller. So we can also program this ESP8266 microcontroller with Arduino IDE. So after connecting it to our program, we can program for a particular project using Arduino IDE itself. So next we will see how to do that. So how we can program this node MCU using Arduino IDE means, first one we have to go to open the Arduino IDE, like Arduino IDE which have installed in your system. Then after that, in that go to a file menu. There you go to a preference table, and there you have to choose the preferences. Then you have to define as it likes. You can see in the picture here. Go to this sketchbook location where there is an additional board manager URL. It will ask where you have to copy this URL. After that, hit enter. Next you have to select the board. So for that you go to boards and go to board manager from the tools menu. So as you can see there, you type ESP8266 and search for it. After you get that, you have to install this ESP8266. After that you connect your ESP8266 microcontroller through micro USB cable and select the board in the Arduino. So then go to tools. There you can see the board where you can find out a node MCU ESP8266 module. Then you have to select this, and then after that you can program and dump the program in that microcontroller. So this is a sample code for in order to control LED through a HTTP page using node MCU. So you have to include some of the header files here. As you can see, libraries, ESP8266 Wi-Fi library, have to include Wi-Fi client. This is in order to use the HTTP, you have to use the ESP8266 web server library. So these are the different libraries you have to include in this program. So this is the sample code. You can write your own program according to the specific project which you are using this node MCU. So it has a inbuilt Wi-Fi. It has that password for it. That password and Wi-Fi ID you can change. So next we will see a simple program in order to connect a LED. So as I told, this is the simple program here. So next we will interface an LED to this node MCU microcontroller and will write a Arduino program. So this LED, as you can see, it has mainly two pins. One pin has to be connected to ground. The slightly bent pin has to provide the power supply. So that I am connecting through a resistor and providing to pin number D1 of this node MCU microcontroller. So next we'll write the program and we'll dump the code. So this is the sample code for this LED blinking. So I have connected to pin number 1. So I am mentioning here int LED as 1. After that we have to set up as LED I am using as output pin. So in the pin mode I have to give it as a output. So pin mode of LED I am giving as output. After that we have to write the actual code in loop. So here as I connected to digital pin, I am using a digital write of LED making high. Is nothing but in order to turn on the LED I have to provide a 5 volts supply, that is a high means I am giving. So at that moment the LED will be glowing, that is turned on. After that I am giving a delay of 1000 milliseconds. After 1000 milliseconds of delay, again have to turn off this LED. For that I am using digital red of LED I am making low. So this will turn off the LED. After that again at 10,000, that is 1000 milliseconds of delay I am giving. In this way you can turn on and turn off the delay after 1000 milliseconds of delay. In this way you can interface LED with ESP8266 microcontroller. So what are the application of this node MCU means you can use for IoT applications, low power battery operated application, wherever you want to send the data, like in project you want to send the data through a net Wi-Fi, means you can use this. In order to connect to Blink app you can make use of this node MCU ESP8266. Like project including Wi-Fi and Bluetooth functionalities, you can make use of this node MCU. So in this way you can make use of this node MCU ESP8266 microcontroller in different projects. So thank you for watching the video. Thank you.